first thing is we need to we can draw a horizontal line here, and this angle should be equal, angle theta. How come these angles be equal? We study that in the diagram of the inclined plane. We prove these angles to be equal. In case we have not done with this, we'll be studying this one in the drawing of the inclined plane. We'll show that these two angles are equal. So that's the first thing. And the tree is in equilibrium, which means we can apply the principle of moment, and the pivot is mentioned as the point Q. How many forces do we have? I can see a force of 1800 Newton, and there should be a weight of the tree. It should be exactly through the middle. The center of gravity is also marked, and the weight of the trees we don't know, so I'll just note down from the data. If we somehow know the weight of the tree, we don't know, but instead mass of the tree is given. Mass is given as 270 kilograms, which means the weight should be 270 times 9.81. How much should it be? 2649. 2649 Newton. That's the weight of the tree. How many forces do we have? Well, we have two forces, and we'll try to simplify the diagram. So one of the forces is very okay. It is vertical. Okay, and we know the perpendicular distance of that force from the pivot. How much? 1.2. So 2649 force, that force is a good one. It's not going to make any problem for us. Meanwhile, this force seems to be tricky. So this force is 1800 Newton, is upward. I can also draw it over here. I mean, the force is same, 1800. And I really want to get rid of the tree, because we don't have the perpendicular distance between pivot and that force. The direction of force is this one. So we draw a line here. We draw a line parallel to this one through the pivot. That should have been the perpendicular distance. Do we have this distance? No. Find the distance of that force from the pivot using the trigonometry. So we need to find, technically, we need to find this distance, the perpendicular distance between these two. This distance needs to be found out. So what can be done? Let's consider this angle. That's why I drew this one, angle theta. Consider this triangle. This one triangle. Consider this. Just try to visualize this thing. So this, for this triangle, if I write down the expression for cos, because I know the base of this triangle, 1.6 is the base. The base of the triangle is given as 1.6. So base of the triangle is cos theta equals to base over hypotenuse. What is the hypotenuse? We don't know. X. This one unknown. This is x, which means this distance equals to 1.6 divided by cos theta. So we have found We have not found the value of the distance, perpendicular distance of that force, but we have found the expression in terms of theta. Now the new diagram looks something like this. If I try to draw the new diagram for your convenience, the new diagram, other than every irrelevant thing, it should look something like this. We have a beam. This distance is 1.6 divided by cos theta. Looks unusual. This is not a value of distance. This is just an expression. The angle was given as theta. The force on this side is 1800. Pivot is here. So we do have the perpendicular distance of this force from the pivot. How much? 1.6 divided by cos theta. There is another force over here, which was, I can even erase this thing. We don't even need this. This force was 2649. And the perpendicular distance of that force from the pivot is also given. How much? 1.2 meters. And once again, if you struggle to find the perpendicular distance of a force from the pivot, this is a method. Very important one. Draw a line in the direction of force. I want to find perpendicular distance of this force from the pivot. I draw a line in the direction of force. I draw a line parallel to that one, but I make it pass through the pivot. It will look like this. The distance between them, the shortest distance between them, is the distance of that force from the pivot, which in this case is 1.2. Let us now apply the principle of moment about the point Q. Clockwise, this one is CW, this is ACW. So CW is clockwise is 2649 times 1.2 equals the anti-clockwise. How much is the anti-clockwise? 1800. What is the perpendicular distance of that force from the pivot? We don't have a numeric value. We do have the expression 1.6 divided by cos theta. All you need to do is please take a calculator. Cos theta equals to 1800 times 1.6 divided by 2649 multiplied by 1.2. 25 after the cos inverse. So the only problematic part in this question was this angle right over this distance right over here, the x. This is the only problematic part in the entire question. Now what I've done here is I have resolved the force 1800 Newton into two components. The top component, the vertical one, should be 1800 times connected with the angle, so cos theta. 1800 times cos theta, and the other one should be 1800 times sin theta. This one can be 1800 sin theta. This is not connected to the angle, to the given angle. 1800 sin theta. So do we have the perpendicular distance of this force from the pivot? 1.2. So 2649 times 1.2, and this force is clockwise. This one is anti-clockwise. How much is it? 1800 cos theta times the perpendicular distance of that force from the pivot. How do we find perpendicular distance of that force from the pivot? It is given already. Draw a line in the direction, draw a line parallel to that one through the pivot. How much is it? 1.6. Multiply by 1.6. So this is the expression that most of the students were writing for this question. The biggest problem was where many of the students were failing to understand that there is still another force, another component of the force which would also produce the moment, because that force does not pass through the pivot. Which one? I'm referring to this one. Now think about it. Is this force passing through the pivot? No. No, it's not. In most of the questions that we get from this topic, the thing is, whenever we draw the components, what usually happens is one of the component is used and the other component passes through the pivot, except for this question. So this also produces moment. Which one? Anti-clockwise. So it moved the tree in this direction, anti-clockwise. What is the perpendicular distance of that force from the pivot? It would be one arrow in the direction of force, one arrow through the pivot, and the difference between these two is the perpendicular distance. How much is it? Probably we need to find it. Consider this triangle. Now for this triangle, the perpendicular distance would be the perpendicular of this triangle. This one. This is a perpendicular distance. The shortest distance between the two lines. For the given triangle, it is equal to the perpendicular of that triangle. How much is it? I mean, we don't know the exact value. We can do some mathematics here. So for example, tan theta for the given triangle equals to perpendicular over base. Base is 1.6. So the given unknown distance, I'm going to call it, let's say, D, or let's call it H. This one, let's call it H. That equals to 1.6 tan theta. So there is another anti-clockwise force. Sorry, there is another force that produces anti-clockwise moment, which is 1800 sine theta. That's the value of the force itself, which is in terms of an angle, in terms of theta, times the perpendicular distance, which is also in terms of the angle theta. So that's why if you resolve the force into components, the expression becomes tricky. So what do you get is 2649 times 1.2, 1800 times 1.6 times cos theta plus 1800 times 1.6 times sine theta into tan theta can be written as sine theta over cos theta. What you do is multiply by cos theta, both sides multiplied by cos theta. both sides multiplied by cos theta. So this side with cos theta, the first term on the right side, there are two terms. So the first term is multiplied by cos theta as well, which should be cos square theta, plus the second term is also multiplied by cos theta, and cos theta should be cancelled out. You should be left with this thing. How? This one as it is, 2649 times 1.2 cos theta. You take this thing common because this term is being repeated. 1800 times 1.6 here, 1800 times 1.6 here, 1800 times 1.6 is taken common. What are you left with? Cos square theta plus sin square theta. 2649 times 1.2 cos theta equals to 1800 times 1.6, and the value of cos square plus sin square theta, cos square theta plus sin square theta is 1. So cos theta equals to 1800 times 1.6 times 1 won't make any difference, divided by 2649 times 1.2, and if you take cos inverse of the answer on the right side, you get the same answer, which is 25.